Hi everyone. Uh, my name is Surapol Vorapatratorn. Today we would like to present our research development of automatic plant factory control system with AI-based artificial lighting. And we come from the Center of Excellence in Artificial Intelligence and Emerging Technology, School of Information Technology, Mae Fah Luang University. For the background, in the next 10 years, for the threat of the agricultural population will decline to the contrast to the urban population growth. So the world population will face the future food stock shortage. Recently, agricultural research has been primarily focused on ways to produce more food with a future resource. And in the plant factory is a novel architecture solution to solve the limitation result. For the plant factory, cropping requires knowledge and accuracy in the setting up and the matching. The proper setting leads to the excessive resource consumption, power consumption, and low quality production. So for our proposed method, we propose the development of automated plant factory control system with the AI-based artificial lighting without the required user expertise or knowledge. And we aim to developing the plant growing AI model in the three models. For the first is a high quality model. The second one is safe energy model. Then the last one is a low waste model. For the first, we would like to introduce how to plan factory design. For the first is a structural design. In our design room, in the plant factory room, we contain the 5 elements. For the first is a control room. In the control room, it include the computer which have the AI automatic control, the sensor and the controlling system in the plant factory room. The second one is sterilization room in this one, and the next one is painting room, this one, and the next is a packaging room here. The last one is nutrient storage section. The nutrient storage section is out of the painting room, is outside of room. For the fan factory design, then this is our design. You can see that we have the 62 plants per one section and the 16 sections per one crop. You can see we have the 16 crop here. For we name the crop in the A1, A2, A3, A4, and B, yeah, in the row and in the column for the B, C, D. So we have totally 256 sections, and every different new in the different nutrient and life pattern for each crop. This is the example picture from our plant factory room. This is the outside of the room, and this is the inside of the room. You can see that for one crop, we have 4 levels for planting each plant. For the next plant factory design is the water circulation. For the water circulation, in the one nutrient solution tank, we use the one nutrient solution tank per 2 crop. Capacity of the 100 liters per tank, and the water pump in each tank direct the nutrient solution to the top of the crop. and we use the reverse osmosis purify water, or we can call the RO water. And in this tank, you can see in the picture in the blue one, in this tank, this consists the electrical conductivity sensor, or we can call EC sensor, and a water pH sensor here. So you can see the example of the water circulation here. You can see the clean fine line. This is will bring the water and nutrition solution to the to each crop. The next one is air control and lighting control. We use the 4 fan per 1 layer and 16 fan per crop. You can see in this diagram. And for air circulation of plant directly affect to the process of the plant growth. The LED that we use, we have the 4 types. The first one is white light, another one is red, the next one is blue, and the last one is far red. So we can adjust the brightness and light spectrum from the controlling system. For the next step is AI training. For the first step of the AI training is collecting data. We collect the data in the database every 5 seconds. The data that we have collect include the temperature, humidity, carbon dioxide, nutrient solution concentration, pH value in the water, and the total weight of the plant, and the total waste, and the last one we collect the total electricity used. In this picture, you can see that in the outside of the room we have the a big 3 LCD to monitoring inside the room. So you can see the picture of each crop here, and you can see the total room here. And in the example part is a real-time sensor data that show in the middle LCD here. The LCD in this monitoring LCD, the data collect from the plant that upload to the online database, and the value is shown in the real time. The next step is a planning plan. For the planning plan, we plan 4 types of plant. The first one is butterhead. You can see here the butterhead. Another one is fillet iceberg. Another one is kale. The last one is Thong Ho or Guangtung in Thai word. And the plant phase, we have a 3 phase of plant. The first one is a germination in the 7th day. Another one is a seedling stage, 14 day, and the last step and the last phase is a vegetative state in the 21 year. In the vegetative state, we start to lighting the LED pattern direct to the plant for in the start in the vegetative state. The next one is the feature. This feature we use to training each AI model. For the feature, or we can call the attribute, it contains 9 attributes. The first one is day or the age of plant. The rank is in the 1 to 30. another one is the hour of day, another one is the minute of hour, another one is the EC or electrical inductance in the water, another one is the pH, and another one is air temperature. The next one is humidity or air relative humidity in the percent, and the next one is carbon dioxide in the air, and the last one is the water level in the tank. All these features we collect in the CSV file and upload to the server every 5 seconds per one record. In the algorithm that we use to training the AI, we use 4 algorithms to compare the performance of accuracy, training time, and the prediction speed. We use the artificial neural network. Another one is a support vector machine or SVM. Another one is decision tree, and the last one is naive. So we compare the performance of each algorithm and select the best one to use in the real application. This is a result for the AI training that you can find that the ANN algorithm is lead the most score in the accuracy in the 98.3235%, and the best one for the speed, or we can call the prediction speed, in the 90, 100 and 70 90,070 record per second for the prediction speed. So we choose ANN to implement with our AI automate control system. For the result, we collect the plan from our clock, and we using the scale to measure the weight of plant, and we also collect the electricity used and waste of each clock. For final experiment, we use the automate AI model to plan our plant, and we have the 4 experiments. The first one is we using the AI general model. You can see that when we use the AI general model, the total of weight is the most one. Another model is AI low waste model. So you can see that in the result, the A2 model or AI low waste model reach the minimum of waste that using in the planting. And for the third one is the AI safe energy model. You can see that the energy or electricity used is the minimum using when compared with another planting. And for the last one is a non-AI model. The result show here. Okay. And for the next, we would like to show you from the our pen factory, and we have a little of the video. Is maybe you can more understand what we working with the pen factory. This is the experiment for the LED spectrum. you can see that in each LED it can be adjustable. This is our plant factory room นะครับ and this is the product line room when we would like to plant the plant. This is a air circulation system. Okay, for finally, when we finish our experiment, we can see that in the clean room planning system, in the building had a relative high cost, and when you planting in the same room, the temperature and humidity is hard for control. That the plant in the same room need to use the same control for the temperature and humidity, and it cannot adjust in the separate temperature in each cup. The and for the suggestion, we suggestion you to planting in the container planting. When you planting in the container planting, you can use less costly than indoor planting, and allow us to better control the temperature and humidity, because you can separate each cup in each container. Okay, so we would like to thank you everyone, and thank you the 13th International Conference on Information Technology and Electrical Engineering, or ICITEE, that accept our research นะครับ and if anyone have the problem and if anyone have a question, you can ask me now. Thank you.